Hope all of you are doing well. Today we are going to discuss the Vernier calipers experiment of grade 12 physics practical. Whenever we are doing the vernier experiment, we will have some doubts like why should we use vernier instead of meter scale for measuring the lengths, right? So actually vernier is used for measuring small lengths accurately and correctly up to a fraction of a millimeter. It can be used to measure the length of small objects, to measure the internal diameter of beaker, also to determine the surface area and volume of the sphere. Here we are going to measure the diameter of a small spherical body, that is the bob of a simple pendulum, by using the vernier calipers. Here this is the aim of our experiment, and also for exam the question will be given to you, that will be the aim itself. So whenever you are writing the answer, you can copy the question itself as the aim of the experiment. Here the apparatus required is vernier calipers and a spherical body, that is a pendulum bob. And whenever we are writing the theory, here we have to find the diameter only, right? So that only the total reading we have to find. And to calculate the MSR reading, that is the main scale reading just before the zero of the vernier, and that we will represent as MSR in capital letters, and also we can mention it as capital N. Okay, and the vernier scale reading is the vernier reading which coincides with any of the main scale reading, and that we will represent as VSR, vernier scale reading. And whenever we calculate the total reading, we have to multiply the vernier scale reading with the least count. What is least count of a measuring instrument? That is the smallest value of a physical quantity which can be measured accurately by the instrument, right? So whenever we write the diameter of the sphere, we have to write the total reading as MSR plus VSR into least count. That VSR into least count is within bracket. You have to do that calculation first and then add with MSR, and then we have to just mention what is MSR, VSR and least count. That is MSR is the main scale reading, VSR is the vernier scale reading, and LC is the least count. Only that much we have to write for the theory part. Here we can see the diagram of a vernier caliper. There are two scales here, that is main scale and vernier scale. Main scale is similar to a centimeter scale, and here we have 0 to 10 centimeter in main scale, and vernier scale is a small scale fitted on the top of this main scale, and there are 10 divisions on vernier scale, and we can see two jaws, and one is movable and the other one is fixed jaws, and in between the jaws we have to keep the object which one we want to find the dimension, and the screw is used to make it tight. Okay, these are the main parts of the vernier calipers, and we can see how we will do the experiment. Before starting the experiment, we have to calculate the least count and the zero error of vernier calipers. We know that least count of vernier calipers is the least value or the minimum value that can be measured by using vernier, right? So in order to calculate that, we have least count is equal to value of one main scale division divided by number of divisions on the vernier. So these two values we know, that is one MSD or value of main scale division is 1 mm, right? And the number of divisions on the vernier is 10. So we can substitute the value. LC is equal to 1 MSD by N, that is equal to 1 by 10, that is 0.1 millimeters or 0.01 centimeter. That is the least count or vernier constant of vernier calipers. This observation part you have to write on the left side of your notebook. In order to find out the zero error of the vernier, we have to keep both the jaws together, and if the zero of main scale matches with the zero of vernier, then the error will be zero error. If both the zeros are not coinciding, there will be error. From the diagram it will be more clear. Here we can see that the zero of the vernier and the zero of the main scale look like a single line. That means it coincides. There will be no error in this case, that is zero error. When we keep both the jaws together, if the zero of vernier scale remains on the right hand side with the zero on main scale, then error is said to be zero error, that is positive error. Here the reading taken will be more than the actual reading. Hence we have to apply correction. Suppose we are getting 2 as the error, then 0 error will be 2 into least count, that is 0.02 centimeters. For getting the true value, we have to find that observed reading minus 0 error. So that will be the actual value. From the diagram we can see that the main scale reading and the vernier scale reading are not coinciding. That means there is a positive error. If there is a positive error, there is a chance for getting negative error also. That means if we are keeping both the jaws together, if the 0 of vernier scale remains on left hand side of 0 of the main scale, then the error is said to be negative error. Here the reading taken will be less than the actual reading, hence we have to apply the correction. Suppose we are getting 2 as the error, then the 0 error will be 2 into least count, that is equal to 0.02 centimeters. Then the true value will be equal to observed reading plus 0 error. Here we can see the negative error, that means the main scale reading and the vernier scale reading are not coinciding here. From the given diagram we can compare the 3 errors. In the first case there is no error, and in the second case there is positive error, and in the third case there is negative error. Usually in most of the vernier calipers the zero correction will be 0. So no need to apply correction, we can directly do the experiment. Now we can start our experiment to find the diameter of the sphere. For getting the diameter, first of all we have to keep the sphere in between the two jaws and make it tight. Then we can take the readings, that is the main scale reading and the vernier scale reading. In order to find the main scale reading, we have to take the measurement from the main scale, and it should be just before the 0 of the vernier. Here we can see with a red mark, that is after 1.3 is the exact reading. It is just before the 0 of the vernier, right? So MSR will be 1.3. And in order to find the VSR reading, VSR is the vernier scale reading, and that should coincide with any of the main scale reading. Okay, so we can check that which division is coinciding with the vernier. And one important thing is that it should be a number from 0 to 10. Okay, that means we have to check each division on the vernier with the main scale. Here we can check the first division, that is 0 of the vernier. Is it coinciding with the main scale? No, it is not coinciding. And now we can move to the first division. First one is also not coinciding. Second is also not coinciding. We can see that the third one, that means the vernier scale reading 3, that coincides with the main scale. That means here we can see both lines look like a single line. So here we can take VSR as 3. Now we can move to the tabular column. Here we have the tabular column with the MSR, VSR, and in the next column we can make VSR into least count, and then the total reading, that will be MSR plus VSR into least count. So that we can write the MSR as 1.3 and VSR 3, and then we will multiply that 3 with 0.01. So that value we have to add together to get the total reading. In the similar way we will repeat the experiment for minimum 5 times, and then we will tabulate the values. When we repeat the experiment, we will get almost the same reading for MSR, and there will be difference in VSR readings. That means that the slight changes only will affect the VSR value. So that we have to calculate the total reading, then find the mean of that in order to get the diameter of the sphere. Whenever you calculate the mean, you have to write the unit also. Here we are finding only the diameter, so that we can calculate the mean value only. Then we can write the result. The diameter of the given sphere is equal to that much centimeters, and we have to write down the precautions and sources of error also. Hope it is clear to you. Now we can conclude the video here. If you like my video, please like, share and subscribe. Thanks for watching.